Hello, this is a factoring refresher to get us ready for our rational expressions and functions unit. All right, so just a quick reminder, how do we factor polynomials? So we're really going to kind of use this flow chart. And for the most part, we're going to focus on 2 and 3 term polynomials. We will get to 4 terms, but we're going to start with this. So here's this a little bit bigger picture of that. So first, we want to look for a greatest common factor. So your very first thing we're always going to start with is can we find a greatest common factor? And if so, we should factor that out. Then we want to determine, okay, does the polynomial have 2 terms? Like these kinds of problems. And if they do, then check for difference of 2 squares. If it has 3 terms, then we really have a couple options. It could be a trinomial with a leading coefficient of 1, or a trinomial with something other than 1 as its leading coefficients. And then lastly, does it have 4 terms? And if it has 4 terms, then we probably want to try something like grouping. But today we're really going to focus mostly on this portion over here of the flow chart. Okay, and we'll come back to some of these problems, examples that are at the bottom of this at the end of this lesson. Okay, so let's just go over factoring by GCF. So the first thing that you want to do, I just kind of wrote some steps over here, is you want to find the greatest common factor of all the terms, and then you're going to put that out in front and put some parentheses and figure out what goes inside the parentheses. And then to figure that out, you're just going to divide each term by the GCF and then write them in the parentheses. So in this particular case, excuse me, you'll notice that both of these terms have an x in common. We want to look at the coefficients here. I also see an 8 and a 20. So the biggest number that goes into both 8 and 20, or the greatest common factor there, is 4. So if they have a 4 and an x, that's our GCF. So I want to write 4x in front, and then I'm going to put a parenthesis. Now I just need to figure out what goes inside the parenthesis here, right? So I'm really kind of working this distributive property backwards. That's really what factoring is. It's still the distributive property. So I'm saying 4x times what gives me 8x squared. Or another way to think about that is 8x squared divided by 4x gives you what? And that's 2x. And then 4x times what gives you 20x, positive 20x, and that would be 5. So my answer then is 4x times the quantity 2x plus 5. And that is it. That's all there is to it. Okay. So you can get more terms, you can get a little bit more complicated. So you look at this and you try to figure out what your greatest common factor, and you'll notice that all of these have an x squared in common. So then I want to look at the coefficients and figure out what does 18, 12, and 24 have in common. What do they all have in common? Would be the greatest common factor would be 6. So my GCF here is 6x squared. So I'm taking that out of every one of these terms. So 6x squared times what gives me 18x to the 4th, and that would be 3x squared. Again, if you go this times this, you should get this back, right? Okay. And then 6x squared times what gives me 12x to the 3rd? Well, 2x. And then lastly, 6x squared times what gives me negative 24x squared? Well, that would be negative 4. And then after that, as we'll learn a little bit later, we'll try to factor this if we can. Okay, but there we've taken out a greatest common factor, and then you can go from there if you need to. All right, and one more. All of these, you'll notice they don't all have an x in common. So then we're just going to look at these coefficients here, and it looks like the greatest common factor there is 3. So I'm going to take a 3 out, And that would leave me with 3x to the third minus 1x, or just x, and then plus 8. Again, if you distribute like this, it should give you this answer back. Okay, so that is just a quick refresher on factoring by GCF. Hopefully that rings some bells. Okay, the next thing is when we have two terms, what do? Okay, if there are two terms and they're both being subtracted, like this, and both of them are perfect squares, then you can use the difference of two squares, which is really, difference of two squares is the two terms are actually something that is both squared. Then you can rewrite it as a plus b times a minus b. This probably makes some sense, and we're going to kind of go back to this in a bit. But really, there's no bx term. So if you remember, how do we factor two things, or x squared plus bx plus c? We're going to go over that in a bit, but two numbers that multiply to be this, but add up to be this. Well, this time we don't have this. This is gone. So it's really like a 0x. So we're asking two numbers that multiply to be c, but add up to be in the middle, 0. That's really what this is. And that those are always going to be, I want the eraser, there we go. Those are always going to be opposites of each other, which is why this is a plus b and a minus b. Okay. And then all of the perfect squares are highlighted on the diagonals, right? Because they're 5 times 5 is 25, so that's a perfect square right there, etc. So we're going to look at these. X squared is a perfect square. If I take the square root of that, I get x. The square root of 16 is 4. So then this is just x plus 4 and x minus 4. That's how you factor those. So 144, you'll notice that's on my chart. That's right there. Okay. And that's 12. 12 times 12, right? So I know that x squared is a perfect square. That's the square root of that is x, and the square root of this is 12. So this would be x plus 12, x minus 12. That's the factored form of that. Well, we know that x squared is a perfect square root is 1. Yeah, 1 times 1, right? So this would be x plus 1, x minus 1. Okay, 100 is as well, right? Let's look at our chart. There it is. And then also the other one there is 64, so both of those are perfect squares. Okay, so now you look at the exponents, and you see x squared. Well, that's a perfect square as well. Well, y to the 6th is 2. It's even exponent, so pretty much any even one is going to be perfect square. So this is 10. The square root of this would be 10x. The square root of this would be 8y to the 3rd. So then I would write this as 10x plus 8y to the 3rd, 10x minus 8y to the 3rd. There we go. Yeah, so that's all you got to do. There's a square root of both of those. And then we're just going to write x squared plus 5y to the 5th, x squared minus 5y to the 5th. And that is just a refresher on difference of two squares. But again, you can only use it if it's subtraction. There's two terms, and they're both perfect squares, which I've kind of highlighted up here, but key thing to remember. If you see x squared plus 16, you can't do this. Okay. All right. So how do we factor polynomials that are quadratics in the form x squared plus bx plus c, where my leading coefficient here is 1? Well, we want to look for two numbers that multiply to be this one right here, but also add to be b. So let's take a look. We should have done this quite a bit last year, but you are going to start by looking for numbers that multiply to be 24, right? So factors of 24 would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. So you can write them out. You can use a multiplication chart. You can use your calculator. But hopefully you'll start to get pretty good at this. The better you are at your times tables, the easier this is. But then you're going to look at those pairs, right? And you're going to say, which pair of those also adds up to be 11? Well, the only one that adds up to be 11 there is 3 and 8. So when I factor this, I'm going to have two binomials. I know in order to get x squared, I need an x here and an x here, right? So then my two other numbers are positive 3. I'm going to use these pair right here and put them in positive 8. The order doesn't matter as long as the signs are correct. So the factored form of this trinomial would be x plus 3 times x plus 8. If you were to multiply this out, you would get this back. So, yeah. So let's try another one. You can start by just doing this every time for these kinds. All right, two numbers that multiply to be 56 and also add up to be 15. So if you wanted, you could go to this chart right here, look for 56 on your chart, okay, and find out, there it is, right? What numbers multiply to be 56? 8 and 7. And now does that also add up to be 15? Yeah, 8 plus 7 is. So this would be x plus 7 times x plus 8. Okay. So then you also have to be careful because sometimes there's negatives involved and that does matter. So when I'm looking at 18, I know that the factors of 18 would be 1 and 18, 2 and 9, 3 and 6. But now I also need it to be negative 18 and it has to add up to be negative 3. So you're going to have, in order for numbers to be negative, if you're multiplying, one of the numbers has to be negative. So, right, I can see the difference between these two is 7. So the only two numbers I could get if I put a negative on there would be, like if I put a negative here, that would give me 7. If I put the negative over here, I'm going to get negative 7. That's not going to get me negative 3. So that one doesn't work. These two are 3 apart, so that's how I'm going to get to here. So now I just got to figure out where does the negative go. Well, if I go there, negative 3 times 6 does give me negative 18. But negative 3 plus 6 gives me positive 3, which is not what I want. I want negative 3. So that means the negative has to go on the other one, like this, because 3 plus negative 6 does give me negative 3. So this is x plus 3 and x minus 6. There we go. Okay. And then this one, you'll notice I have a positive 32, but in here I have negative 12. Huh. Well, two numbers that multiply to be 32. You have a couple of 2 and 32, 2 and 16, 1 and 32, 4 and 8. 4 and 8 gets me 12, but I need negative 12. But I also need this to be positive. So what do I do? Well, if I make them both negative, negative times a negative gives me a positive when I'm multiplying, and then negative 4 plus negative 8 does give me negative 12. So there we go. We did it. Okay, that's factoring x squared plus bx plus c. So how do you factor when your leading coefficient is something other than 1, like a 4 or a 7 or whatever? So these are some steps. It's kind of a ninja trick to use, but I do like it. You'll see a variety of ways. to do this. But I like this. So you're going to write your trinomial as x squared plus bx. In other words, no a in front. And then you're going to say, well, all right, I'm going to put whatever a times c is in the blank. So you're going to write it in the blank. And then you're going to factor that polynomial just like you normally would because there's no leading coefficient at that time. But that's not enough. After you do that, then you're going to take whatever your leading coefficient is, your a value, and you're going to put it underneath both of the numbers. Reduce. If there's any denominators, then you'll move in front of the x. Okay. So here we go. We're going to try this. I'm going to have the steps right here. So I'm going to write this as x squared plus bx. So I'm not going to write the 6 here. I'm just going to go x squared plus 19x. And I'm going to put a blank. Now, my a is 6. My c is 10. So I'm just going to go 6 times 10. And I'm going to write it right here, which is positive 60. Okay. Now, it says to factor that polynomial. So I'm going to factor it. Now, you might spend a little time on this step, but whatever. When you do, eventually you're going to run across two numbers that multiply to be 60, but add up to be 19 are 4 and 15. 4 times 15 is 60. 4 plus 15 is 19, so that's what we want. Okay, cool. So now I need to write, I'm not quite done. I got to take this 6 here, and it says to divide both of those by a. So I'm going to put this 6 underneath here and here. I'm going to reduce, again, use your graphing calculator if you're not great at reducing, but we want to reduce those two fractions. If I reduce 4/6, I get 2/3. Okay. If I reduce 15/6, I get 5/2. Now, sometimes when you reduce, you're going to get a nice number like, I don't know, 3, and there will be no fraction. But if you have any denominators left, in this case, both of mine have denominators right there, a 3 and a 2, right? I want to move those denominators in front of the x like this. So this goes right in front, and this goes right in front. So this would be 3x plus 2, and this one would be 2x plus 5. That's the factored form of 6x squared plus 19x plus 10. If you were to multiply this out, you would get this back. Okay, so let's try this another time here. So I'm going to start by writing, I suppose I should get in my pen mode. There we go. X squared minus 15x. Put a blank. Inside the blank, 9 times 4, which is 36. Okay, factor. I need positive 36, but this is negative, so two numbers that multiply to be 36, but add up to be negative 15 would be negative 3 and negative 12. Okay, now I'm going to factor, or I factor that. Now I'm going to put the a underneath, and my a is 9, so I'm going to go 9 under here, 9 under here. I reduce, I get x minus 1/3, x minus 4/3. In this case, I have the denominator of 3 in both of them, so this would be 3x minus 1 and 3x minus 4. Done. Okay, one more, because these are a little weird. Just want to make sure that we're real comfortable with this. So x squared minus 15x, and then 4 times negative 4, I'm going to put that in the blank. That would be negative 16. It's a negative this time. Okay, factor this. Two numbers that multiply to be negative 16, but add up to be negative 15 would be negative 16 and positive 1. All right, now I'm going to put the 4 underneath both of these. And I'm going to reduce. This one ends up just being 4. This one ends up being the same, right? Like, that's already reduced. Now, I do have a common denominator left, and that one here is this 4, so I'm going to move that in front. This one will just stay as x minus 4, though, because there's no denominator. There we go. That's the factored form. So hopefully that's a good refresher for you. Here was some problems that we looked at the very beginning. I want to go through a couple of these at the very end here so that we can make sure that these make sense. Okay, so putting it all together. Whenever you factor, you should always start by looking for a greatest common factor. So in those other problems that we just went through, those were just a refresher on how to do the steps. But really, when you do your assignment, you always want to start by saying, is there a greatest common factor? So I'm going to start here. And I say, is there something that they all have in common? Well, this one has an x. No, x, no. So I don't have to worry about that. But 2, 20, and 50 all have a common factor of 2 in common. So I'm going to take that out. And then I'm going to write what I have left, which would be x squared plus 10x plus 25. Okay, cool. Now I need to factor this. And since this thing that's inside the parentheses has a leading coefficient of 1, I'm looking at this kind of situation right here, where I'm going to look for two numbers that multiply to be C, but add up to be B. Okay, so two numbers that multiply to be 25, but add up to be 10, it'd be 5 and 5. Whoops. Okay, so there we go. This is the factored form of this. But again, always start by looking for your GCF. Okay, this one has two terms, but I do see a greatest common factor. They both have n's involved, and 2 and 18, 2 goes into both of those. So this would be 2n is my factor. So if I take that out, I would get 9m squared would be left. And then over here, minus n squared. Okay, now this is a difference of two squares because those are both perfect squares. So let's see. This would be 3m plus n and 3m minus n. Since the square root of this is 3m, the square root of this is n. Difference of two squares. Okay, and then lastly, okay, do these have something in common? Well, they don't have an x in common, but they do have a 3. 6 goes into 30, but it doesn't go into 27, so we're stuck with 3. So I'm going to pull that out. Let's go 10x squared minus 3 times 9. So this would be 9x and then plus 2. Okay, now I need to factor it, and my leading coefficient is a 10, so I'm factoring, again, the stuff that's in here. So, okay, I don't know what I'm going to get yet, but I'm going to start by doing this. Put plus 20 in there. Let's see. Two numbers that multiply to be 20 but add up to be negative 9 would be negative 4 and negative 5. My leading coefficient is 10 though, so I'm going to put a 10 under here and a 10 under here. Okay, I'm going to reduce that, keeping that 3 in front. This would be x minus, so that would reduce to 2/5, and this would reduce to 1/2. Okay, so this would be 5x minus 2 and 2x minus 1. Okay, there it, excuse me, is the factored form of that. Hope this is all making sense and kind of refreshes you a bit on factoring. I would like you to go ahead and try this. Don't forget to write it in your planner as well. All All right. See you later.